Before we look at an example like that, let's take a moment to briefly look at how we can use the normal force and interaction diagrams to analyze systems with multiple objects. We're asked in this case to calculate the normal force that block A exerts on block B and the normal force that the ground exerts on block A given a setup on the right. Now, in order to solve this problem and every problem, I'm going to begin by drawing an interaction diagram, and then I'm going to draw a force diagram for the objects that I'm interested in. In this case, I'm going to be interested in block B and block A, because that's what I'm looking for, the normal force that block A exerts on block B and that the ground exerts on block A. So please pause the video, take a moment, draw an interaction diagram, and then draw force diagrams for both blocks before proceeding. All right, I've gone ahead and drawn in my interaction diagram. And now I've taken that interaction diagram and drawn force diagrams for both blocks B and blocks A, labeling my forces. I'm going to go ahead and also identify the Newton's third law pair here, the force that A exerts on B and the force that B exerts on A. I know those will be equal. Now, in order to solve for the normal forces, I'm going to first write a Newton's second law force balance or force equation in the y direction for both blocks, right? This is the adding forces part that we talked about in our previous video. So if I were to add up all of the forces in the y direction for block B, it would look something like this. I would take the force that A exerts on B and subtract the force that the Earth exerts on B. If, again, we're calling up and right to both be positive, I would call then down negative. So if I were to sum the forces for block A, it would look like this. The sum of the forces in the y direction would be the F of the ground on A minus the force of B on A minus the force of the Earth on A. Right? Both of those forces, the force of B on A and the force of Earth on A, are pointing down, so they get a negative sign. Now, that's not Newton's second law. That's just the sum of the forces. So if Newton's second law looks like this, right? The sum of the forces in the y are equal to mass times AY, then that means I will take all of this and plug this in here for the sum of the forces in the y direction. So I will get something that looks like this. Force AB minus force EB is equal to MAY, but I know again that AY is 0, so what that tells me is that the force that A exerts on B must be equal to the force that the Earth exerts on B. And similarly, for block A, I can do the same thing. I can write out Newton's second law in the y direction. Then I can take this whole thing and plug that in here for the sum of the forces. Then I would get FGA minus FBA minus FEA is equal to MAY, which again is 0. And because I was asked specifically in this problem to solve for the force that the ground exerts on A, or this FGA, I'm going to move the other two forces to the other side and get that the force the ground exerts on A is equal to the force that B exerts on A plus the force that the Earth exerts on A. And I'll also point out that, again, remember that this FAB and FBA are the same thing, so these are equal to each other. I could write that on the side here. FAB is equal to FBA. Again, this is by Newton's third law. Okay, so now I have everything I need to solve for these quantified. I can go ahead and begin plugging in for the force that the Earth exerts on B. That would be what? The mass of B times lowercase g, right? Which would give me, the mass of B is 4 kilograms times 9.8 meters per second squared. That would mean that the force that A exerts on B is equal to 39.2 newtons. And similarly, then I can take this value and plug it in here for FBA, because I know they're equal. That would be 39.2 newtons plus the force that Earth exerts on A, or the mass of A times G. Right? That would give me my force of G on A, which would mean that my force the ground exerts on the A block would be 39.2 newtons plus the mass of A, which is 20 kilograms, times 9.8 meters per second squared, which is a total of 235.2 newtons. All right. And so I was able to solve this problem first by creating an interaction diagram, then by taking that interaction diagram and creating force diagrams, identifying my Newton's third law pair, then writing out the sum of forces in each direction, and then using Newton's second law to take that sum of forces, set it equal to the acceleration, and then solve for what I needed to. So this is actually just a somewhat basic example of how to use the normal force when you have multiple objects, which is not to say that it's not complex. But in this case, because nothing's accelerating, it makes the problem a bit easier to solve. Now let's take a look at when the normal force is a little bit more complicated, in this case for angled forces.